Good morning, everyone. Hopefully everybody is okay and recovered from the session we did on Monday. We're going to carry on today with... sorry, I lost my train of thought then. Chemistry 3, Quantitative Chemistry. Morning to, we've got Tanishka, Raoul, Capri, Lily and Grace. Good to see you online. So what we're going to look at today is we're going to take this a bit further now. We started looking at moles, and we looked at this idea that try not to get bogged down with the fact it's a really big number and a word you haven't really used apart from when talking about small furry animals. But actually we just use it as a unit of quantity. So in the same way as we can say we've got a few or a dozen, we can also say we've got a mole of something. And it doesn't matter what that something is, except for the fact it doesn't really make a lot of sense talking about anything other than atoms, because the number's so big that it just wouldn't be useful for us. So we don't tend to use it in everyday language. But from a chemist's point of view, it's absolutely crucial because it's a way for us to count atoms. And we said that actually if we looked at the atomic mass or the molecular mass, that would equal 1 mole in grams. So if any of that sounded a little bit shaky, after this, go back, watch the part 1 video that I did on Monday. It's only about 40 minutes long. Morning, Nico. Morning, Schlack. So make sure you've watched that as well, because that will really help. We then went through and we looked at different ways of balancing equations. Now, I know that Tanishka's gone through and had a look at some of those, and I need to go through and have a look at the work she sent through later on. So again, if anyone's had a go at any of those, either send them through to me or I can send you the mark scheme that goes with them. So you're more than welcome to mark your own on those. But have a go. It's one of those things that it only gets easier with practice. There's very, very few people that can look, myself included, that can look at a balancing equation and just go, that's the answer. It literally just comes with trial and error. And unfortunately, nowadays, a lot of people are quite worried about getting things wrong. But actually, balancing equations is one of those that you can only learn by getting it wrong a few times and then finding out what works. So you've just got to have a go and sort of move on with that one. So just while we're here, I will obviously do the usual question and answer session at the end. And I'll put that onto Google Classroom. After, I'll be running sessions Monday, Wednesday and Friday this week. And then after this week, I'm not going to be running them live, just because, morning Ruby, just because actually trying to work out time slots being the holidays is going to get quite awkward. But I am still going to produce 3 a week and I will upload them. So if you haven't already subscribed to the channel, do that. And I'll try and put a link onto Google Classroom as well. And they will also appear on my website, Dusty Trails. So they're going to be appearing all the way through the summer. So if you need to keep ticking over with that, feel free. And I'll be putting some resources on as well. But obviously, that's up to you to look at, but we just won't be doing them live. If I get enough of you come back and go, actually, you've done a video on something, I don't understand it, then email me, because I'll be still picking up my work emails. And I'm more than happy to do the odd Q&A session live throughout the holidays. So just let me know if that's of interest at the time. But it just means they won't be at 11 o'clock. They might be scheduled for 11 o'clock. I need to work it out. But I'm going to be recording them at other times and then just uploading them just for the sake of going through the holidays. Right, let's move on then. So we looked at, let's just put this down here. We looked at C3. And so far we've looked at what a mole is. We've looked at relative atomic mass. We've looked at relative molecular mass. And we've done some work on balancing equations. We looked at a formula that was moles equals mass over molecular mass. Or if we're looking at atoms, we can look at mass over atomic mass. And that was pretty much where we got up to when we did this on Monday. And realistically, for most of today, we're actually not going to do anything extra to that. What we're going to look at doing is applying this in a way that's going to be useful for scientists and for chemists. But not just chemists, any of the sciences that you go into, if you're working with chemicals, we need to be able to use these equations. And really, all I want you to be able to get out of sort of last lesson and this one is just to get good at doing these things. So I'm going to show you how to scaffold. I'm going to show you 2 different ways of doing some of the equations today. One of them works every time, is not as scientifically nice, I suppose. And I'll explain why when we go through. The other way also works every time, but is better for some of the higher level questions. And I'll show you that as we sort of work our way through. Now, I'm not going to go over this again. Oh, sorry, we just go back to, there we go. I'm not going to go over those again on their own. What I'm going to do is cover each of those as we start looking at them in a real world problem. Now, if you think about the fact that as scientists, we need to make chemicals. Now, I'm not even talking about in a lab. So those of you that know me, before I was a teacher, I worked in the food industry. I actually worked in the brewing industry. So I made beer for a living, but I was on doing quality control. So we used to have to make up chemicals. So the sorts of calculations then I was using in a lab day in, day out. So we're not just looking at actually in a lab doing research. Some of these in all sorts of industries, if you're buying chemicals in, if you need to make chemicals up, start becoming quite important. For a couple of reasons. So if I just put in Y quantitative for a minute, if I'm just going to put YC3 for quantitative chemistry, to start with, nearly all of this comes down to money, okay? Because actually what we need to make sure is we need to make sure that we reduce wastage. We need to make sure that we increase yield. So by yield, I mean the amount of product we actually get out compared to what we put in. We also need to reduce the energy usage. And we do that by doing these calculations. Now, the reason these calculations are important, we start looking at wastage, is actually if I know that I need to make a particular quantity of a chemical, what I don't want to do is just throw loads of chemicals together and hope I get enough out. What's better for me to do as a scientist is use the exact amount of chemicals that I need to produce the exact amount of product. Because that way I'm only buying what I need and there's nothing wasted. Also, I'm making sure that I definitely order enough to make sure that I get the appropriate product out of the other end. If I make too much of the product could degrade over time. We're going to be increasing the energy usage, and yes, we'll have a greater yield, but we could also increase the wastage. So that's where these sorts of things are coming in. We're not just doing this just for the sake of actually, let's just really annoy our students with unneeded maths. Okay? Although watching the expression on some of your faces sometimes when you're doing these is quite amusing. So let's look at an example. I'm going to choose, let's choose a fairly straightforward one to start with. Let's say we've got some sodium and we're going to react it with water. And we're going to make sodium hydroxide and hydrogen. Now, as we go through this topic and some of the later chemistry topics, you are going to need to get more experience, and you'll do that with the work that we do at identifying what the chemical formulae are. Yes, it's important to be able to do the word equations, but it's also important to be able to work out what the chemical formulae are as well. So if we are doing this as a word equation, I'll just put this in so you can see. We've got sodium plus water is making sodium hydroxide plus hydrogen. Now, sometimes in the exam questions, what they'll do is they'll give you the words and you'll need to put down the chemical formula for these. And some of the fairly common ones that we use quite a lot in science, like sodium hydroxide, you will be expected to know. In one of the later videos I'm going to go through a lot of hints and advice on how you can work it out as you go along, because actually one of the reasons I like being a chemist is I don't need to remember as much. Most of it I can actually work out from the periodic table and from knowing a little bit of information, whereas if I don't understand that little bit, I have to remember loads. And when you look at a lot of what we do in science, scientists can be quite lazy. I mean, let's face it, when we're writing moles, we generally don't bother putting the letter E in the word, even though technically it's there. So we save ourselves time by missing out one letter. And it's the same thing here. Actually, by understanding a bit more, I don't have to remember as much, which means my life becomes easier. So when we're going through with any of these, step one is always to write out the formula. And that's over the picture again. Let's just move that down. There we go. Step one is always going to be to write out the formula. And this just gets easier with practice. Yes, Lily, you will always be given the periodic table in the exam. If I just go and I'll show you the one you'll be given. If you would you like me to put a copy of the periodic table in the Google Classroom so you can actually start using the one that you have in the exam? It's on the specification, and I'll drop that into the chat now. If you go to, I'll put a copy in the Google Classroom as well. That's the link online to get it from. Yeah, I'll drop a copy of it in there as well. Oh, hang on, just done that. Bear with me. There we go. Yeah, so I'll drop a copy in the classroom as well. But that's the one that you will get given. This is also the document that, as teachers, that we actually teach from. Okay, so everything in there is what you need to know. So it's worth going through. I've known some students print a copy off and actually go through and highlight areas that they know they don't know. And I've also got some spreadsheets that I will also put into Google Classroom later on so that you can actually red, amber, green your own knowledge as well. So I can drop that in and you can go through and use it as a revision tool. But that document I've just put in there, if you go almost all the way to the end, the last sort of couple of pages, the periodic table is in there somewhere. Or you'll just need to rotate it around. But that's the one you'll get given in the exam. Okay. So yeah, you'll always get given it. I've been doing chemistry for quite a few years now. If you think about, yeah, I mean, what am I, 40? So if I started doing science when I was quite young, I've been doing it for 25, 30 odd years now. So actually, I don't know the periodic table off by heart. I know quite a bit of it, but that's literally only from the fact that I've written things out hundreds upon hundreds of times, both when I've been learning it and when I've been teaching it. So lots of students look at chemistry and goes, it's chemistry, it's really hard, I can't do it. And that's not true. It just comes from lots of repetition and practice. And actually, as I said, as science, in science and as scientists, we fail more than we actually succeed. But then we learn why we fail and we improve upon it next time. And that's perfectly normal. That doesn't mean that you're bad at science. That just means actually we need to change something we're doing. Okay? And I'm a really big believer of that. And lots of people say, I just can't do this. No, actually, you're choosing not to at the moment, but we can get better at it. Okay? And that's my job to help you with. So step 1 is to write the formula out. Step 2, as I think Tanishka's already done, is to balance the equation. Okay, and if you need a bit of help on balancing equations, I did this last time round. So go through and have a look. I'm going to put a 2 there. I then need a 2 there, and I need a 2 there, which I think is exactly the same as, yeah, well done, Tanishka. You got that right. So that's the sort of first step to all of these. Now, let's say, for instance, that the exam question said that they want to make, and I'm going to make these quantities up because I just want to prove to you that, again, you can practice doing things like this at home. You don't need teachers to set the work for you on this. You can sort of make up equations, or you can go online and find the equations, and we can just put quantities in. So let's say that I want to make 400 grams of sodium hydroxide. What I want to know is how much sodium would I start with and how much water would I start with. Now, water's maybe not as important here because actually water is quite easy to get hold of. But the sodium, I want to know how much I need to buy in the first instance. Now, this is a little bit like baking a cake. Literally, baking a cake is chemistry. You're actually doing a chemical reaction every single time you cook food. So if you think about the fact that actually, if I want to cook more food, so let's say I was planning to do a meal for my family, I'd got the recipe down and I'd worked out how much ingredients I needed. And then all of a sudden, we were going to socially distance and have a big party, and we had other people coming over and I wanted to cook the same meal. I'm going to need a huge table because obviously we need to still keep distance at the moment. But I want to know how much extra food to get. Well, actually, what I then need to do, and I'm going to wait for the groans from everybody on this one because we're going to talk about ratios and scale factors, but all I would do is scale up my ingredients and then cook it for the appropriate time. And chemistry is exactly the same thing. If I know what I need to start with to make a certain quantity, I can scale it up or down depending on how much I need to make. And pretty much that's all we're going to be doing today, is working out how can we scale up and how can we scale down quantities in order to get the exact amount at the end, or in order to predict how much we could produce at the end. Okay? Now, there's a document that I'm going to drop into Google Classroom a bit later on, and I'm also going to put this on a website. This was something I put together a little while ago, so as a bit of a scaffold. And again, as I said the other day, so I've just had to order myself a new mouse. The button on this one is currently not working properly. So we're going to look at two ways of solving this problem. We'll look at the basic way, which is going to be using this table here. Okay? Right. So this is literally the simplest version of doing this one. And you'll see why I lay this out the way I do. So the first thing that I've already done, I've gone through and I've already balanced the equation. So I've got 2Na plus 2H2O makes 2NaOH plus H2. You will sometimes see on here state symbols. I'm going to put those in because it's good practice to get used to using these. So the sodium is going to be a solid. Water is always a liquid. Aqueous means it's a solution. And G is gas. Now, the first thing we're going to want to do is work out the masses in grams from the question. Okay, so we've got 400 grams and there's 2 of them. So in other words, 800 grams. Those of you that have taught before will realise I do it a slightly different way normally. This is the simplest version, and I will explain some of the limitations of doing this in a moment, okay? So, and yell at me if I keep saying okay. I'm quite aware I've just been saying that quite a lot. What I don't know at the moment is how much of that and how much of that I'm going to make. My next step is to work out the molecular masses of these. Now, even without a periodic table, pretty much all of the exam questions I've seen from AQA, they will actually give you the masses of the atoms in the question. So sodium is 23, oxygen is 16, and hydrogen is 1. So if we go through as we've done this before, NaOH, I've got 23 times 1 is 23. I've got oxygen times 1 is 16. And hydrogen 1 times 1 is 1. We can go through. Correct me if I'm wrong. I'm doing this quite quick and I'm not doing it with a calculator. So the mass of this one is going to be 40. I know that water is 18. Actually, sorry, I tell a lie. I've made a mistake here. Let me just get rid of this for a second. I want to put 400 in here and double up this mass. So 40 times 2 is 80. I'll go through that again because I realised I haven't had enough coffee this morning and I've already made a mistake. So that figure there is the figure that goes there. This scale factor here, I multiply by my MR. So in other words, I've got 40 times 2 equals 80. Water is 18, and I'm going to multiply it by 2, so that's 36. Sodium is 23, and I'm going to multiply that by 2 as well to give me 46. Okay, so that. Hi Heidi. So what we then do, and the whole reason that I do this is I'm going to divide going down the table, and I'm going to multiply going back up again. So, and you'll see why this works. So I'm going to divide going down. 400 divided by 80. And I am going to bring my calculator up for this one. Is 5. Now, this is my scale factor. So what we're saying is that 400 is 5 times bigger than 80. So what I need to do is scale all of these up by 5. Okay? It's fine, Ruby. It's not a problem. It's an open YouTube channel. I have no issues at all. Okay, so 400 is 5 times bigger than 80. So I need to scale all of these up by 5 as well. So if I do that, 5 times 36 is 180. And 5 times 46 is 230. So what this works out is that if I had 230 grams of sodium and I reacted it with 180 grams of water, I would make 400 grams of sodium hydroxide. Okay? I can also work out how much hydrogen gas would be produced if I wanted to as well, which should be 10 grams. Now, this is the moment of truth. If you want to make sure that you've done it correct, what you should be able to do is add up both sides and you should get up to the same number. Because if you remember last time, when we were looking at the conservation of mass, the conservation of mass says that whatever you start with, you should also finish with. And rightly so, I've got 410 grams on this side and 410 grams on that side. Okay, so let me go through all of these steps again, and then I'm going to show you a slightly different way, very, very similar, but a slightly different way of doing it. So to start with, the first thing we do, I always scaffold it, mass, molecular mass, and then the scale factor here. The reason I do that is when I'm doing my calculations, I'm always dividing going down the table, and then I'm multiplying going back up it again. So we're multiplying going back up. The first thing we do is we write the formula out, and then we balance the equation. Step 3 then is to write the mass from the question in grams. So in this case, I knew that I wanted to make 400 grams of sodium hydroxide, so I put 400 grams here. Step 4 is to calculate the molecular mass and multiply it by the scale factor of the balancing equations. So step 5 then, we divide going down and then multiply going back up. So in other words, I divided 400 by 80 to work out that 400 is 5 times bigger than 80. And that just meant I had to multiply these numbers by 5 to scale them up by the same amount. So if you can imagine, if I wanted to bake a cake that was 5 times bigger than the one I had before, all I would do is multiply all of my ingredients by 5, and that would mean I could then bake a cake that's 5 times bigger. Morning, Chris. Okay, so that's all we're going to do, and we're going to spend a bit of time looking at some different examples for this. But we're literally just scaling things up or scaling things down, depending on either how much reactants we're starting with or how much products we want to make at the end. Now, I'm going to show you a slightly different way of doing this one, and I'll show you why. The problem we've got, this scale factor isn't the number of moles here, because we've taken into account these numbers here. Now, on almost all questions, apart from the really high level ones, you'll be fine with this. But there's a slightly better way of doing it. We just need a slightly bigger scaffold system. So let me go through and copy that in now so you can see what I'm talking about. It's alright. Every time I try and copy this table over, my mouse dies. There we go. Right. So this is a better way of doing it, and this is the way that when I've been in training other staff to do it. Yeah, I've just ordered a new mouse this morning, Nico. This is the way that when I'm teaching staff to do it now, this is the way I get to do it. So the first way works. You're absolutely more than welcome to do that one. This is a slightly better way, and I'll show you why as we go through. I'm going to do the same problem again, just so you can see the difference. So step 1 is exactly the same as before. We're going to write in our balanced equation. Okay? We're then going to put in the mass, so nothing's changed now. What we're then going to do is I'm going to put our molecular masses in from before, but I'm not going to multiply them by this number. Okay, so that's the only difference so far. I'm then going to divide down the table as I did before. So I've got 10, 10, 10 on this side, okay? Now, at this stage, so let's have a look. 400 divided by 40 is 10. Sorry, actually, get rid of these ones for a minute. I'll show you why in a moment. There we go. Yeah, sorry, I was just keeping an eye on the chat box as we go through. So 40 divided by 40 is 10. Now, this is where we take into account this ratio here. If you think about what's going on here, and this is the bit that confuses a few students, I'll just spend a minute talking about this. This is my ratios. What this means, and this is one of the reasons we balance it, I would need 2 molecules of sodium to react with 2 molecules of water to make 2 molecules of sodium hydroxide and 1 molecule of hydrogen. Now, let me just see if I can bring in the notes from last lesson for a minute so that we can have a quick look at this. I've got them on here. No, that was on a previous one to that one, I think. Okay, that's fine. Let me show you what I mean with this. Let's go over to this side for a second. If I had, and this is the whole reason for the balancing equation, so this is just a little bit of a recap from last time round. If we didn't balance this, if you look at what we've got here, we have, let's just change colour. I've got 1 hydrogen and then 2 over there. So I've got 3 hydrogens, but I've only got 2 hydrogens on this side. So therefore, somehow I've got a hydrogen that's just magically appearing from nowhere. So what we do to make sure that we have the same number on each side is we balance the equations. And again, if that's something that's a little bit new to you, go back and have a look after this and watch the part 1 video from Monday again. So what we do is we've balanced themselves out and we've put these numbers in here. So what these numbers mean is that I've got 2 molecules of sodium react with 2 molecules of water to make 2 molecules of sodium hydroxide and 1 molecule of hydrogen. Or the other way we could look at it is 2 moles of sodium would react with 2 moles of water, because remember mole is just a quantity. I would make 2 moles of sodium hydroxide and 1 mole of hydrogen. So let's carry on through working this out. So we've divided going down the table. We're then going to do it again. Now, at the moment you'll look at this and go, we don't need to do that. That's fine. You'll see when we get to some more complicated problems why this is really important. So let's go back to purple again, just to try and keep things so that some of you don't panic too much. What is that doing there? Don't know why there's a Z there. Anyway, let's just ignore it for a minute. I wonder if I can get rid of it. Yeah, there we go. So we're going to divide going down again. 10 divided by 2 is 5. And I'm going to copy the scale factor across. Then we multiply going back up the table again. So it's literally just a couple more steps. And you'll see what's going to happen. Yeah, sorry, that was right. So we're going to multiply back up, divide down, multiply back up. And I'm going to do 3 or 4 examples of this today, just so you can see how it works. So let's go through and work it out. 1 times 5 is 5. 2 times 5 is 10 times 10. Multiply that together, gives me 230, which is exactly what I got last time. 10 times 18 is 180, which is exactly what I got last time. 2 times 5 is 10, which is exactly the same as I got when I did this up here. However, what this now means is, if somebody was to actually ask how many moles I'm reacting, I could confidently say that actually to make 10 moles of sodium hydroxide, I would need 10 moles of water but I would only produce 5 moles of hydrogen. And that's not something I could do with the way it worked before. So it just gives me a little bit more information and probably only takes about 10 seconds extra. Let's go through and have a look at a few more examples just before your sort of brain sort of dribble out of your ears for a minute, and we can look at how this works. This method, though, would work all the way through college, in any of the sciences, all the way through university. It doesn't get any harder, doesn't get any easier, but it doesn't get any harder. But however, if you practice this, you just get to the stage where whenever you get a question like this, and I've done this before, where I've been helping people tutor on A-level, and you just drop into the same routine over and over again, and nothing needs to change. So yes, you might be looking at it going, now it's a bit confusing, but actually with a bit of practice, it just becomes routine, and that's where you need to get to. Okay, so let's look at a different example. Let's go through and do magnesium and I was going to go for sulfuric acid. Let's not do that for a minute. Let's do nitric acid. Very similar to before. That's going to make, just because that'll test you a little bit on working out the molecular mass. We're going to make that. Yeah, don't worry, Lily. Everyone's does at this stage. It's not a problem. What I want to do is just go through and do this until it goes click. Okay, if I need to carry on with this on Wednesday, that's absolutely fine. But I promise you I can get you through this. Okay, it's just there's a few more steps to it. So don't worry at the moment. Right, I've just got another equation here. Remember, the first step that we need to do is go through and balance it, which I think is just by doing that. That's all I needed to do. Now, what I want to do in this case, I want to find out how much of this magnesium nitrate I can make if I had 85 grams of magnesium. Okay? So I don't know. All I want is how much of this I can make, and I might want to know how much acid I need to react it with as well. So let's drop in the same table that I had before. Don't worry, you'll get good at this, I promise. I'm going to drop the same table in before, and I'm just going to go through and write in my balanced equation. Okay, so I've done that. I can put my ratios in. I've got 1 magnesium. I've got 2 nitric acids. I'm going to make 1 magnesium nitrate. And I've got 1 hydrogen. If any bit of this you don't understand, let me know. My question has told me I've got 85 grams. But I don't know how much of that I've got, and I don't know how much of that I've got. So at the moment, all I've done is I've balanced the equation, and then I've copied information from the question into this scaffold. Now in the exam, I would realistically just copy this list down here. I wouldn't draw it as a table, but it's easier for you to see where things go. Like I said, as we're going through, if you're looking at this and going, I don't understand this bit, where did he get that number from? Put it into the comments box and I'll pick up on it in a minute, okay? Right, so my first step is to work out the molecular masses, as we did last time, as you guys were absolutely excellent at. Now, we've got magnesium's 24, nitrogen is 14, oxygen is 16, hydrogen is 1. And that's literally just come from the periodic table. So if we just go through and work these out, magnesium, we just know is 24. That's the easy one. Hydrogen is just going to be 2 because there's 2 of them. Nitric acid, let's work that one out. So I've got 1 hydrogen. I've got 1 nitrogen. And I've got 3 oxygen. 16, 32, 48, I think, if I'm right. I'm going to add them up. Just need to move this up a little bit because I'm running out of space. There we go. 8, 12, 13, 63. Let's just do magnesium nitrate as well. Yeah, lots of maths in this one, Nico, but you get a calculator in the exam. I'm doing it in my head at the moment, although I've got a calculator for some of the other ones, but you always have a calculator. And the benefit of what I'm trying to show is actually, once you've got into a routine of doing it, you only have to learn one thing, and everything uses that routine. I'm not going to be changing this routine in any way, shape or form for any of the questions that we do on this. Right, magnesium. I've got one of those. Let's just move this over just a little bit. There we go. Nitrogen. I've got 1 times 2 of those. Oxygen. I've got 3 times 2. I've got 6 of those. That's going to be 96. Add them up. 6, 10, 14. 9, 10, 12, 13. 134. Okay. So that shouldn't be any different to what we did last week. What I'm now going to do is the numbers that I know, let's just change pens, I'm going to divide going down. Obviously I don't know these ones, but I can divide 85 by 24. I am going to get my calculator out at this point. So I'm just dividing down the table. So that is 3.5. Okay. Now, hang on. Oh, yeah. No, hang on. Thank you. Cheers, Grace. Let's just change that. Okay, let's go through it again. That will be 18. There. 9, 10, 11, 12, 13, 14. Brilliant. Cool. Thank you. So, I've divided going down, and I've worked out that 85 grams is 3.5 moles of magnesium. Remember, 1 mole would weigh 24 grams. But if I've got 85 grams, that's 3.5 moles. Okay? Just like, for instance, if I had 2 eggs in a cake and my cake needed to be 3 times bigger, I would be putting 6 eggs in. This isn't any different to that one. All we're doing is just scaling things up and down. Now, we know that 1 molecule of magnesium would react with 2 molecules of this. So therefore, if I've got 3.5 moles here, I'm going to need 7 moles of nitric acid. But this is 1-to-1. I would only need 3.5 moles here. Okay? You don't need to use a scale factor if you don't need to. All I'm saying is if I've got 1 of these and I need 2 of these, so 3.5 moles, 7 moles. Again, let me know if that bit doesn't make sense and I can go through that again. Absolutely fine. All I do now is multiply back up my table. So 7 times 63 is 441. Multiply those together because we're going up. 3.5 times 148 is 518. And that's my answer. So I haven't done anything different. 85 grams of magnesium would need to react with 441 grams of nitric acid, and I would end up with just over half a kilo of magnesium nitrate salt. Let's do another one. Oh. Again, if you're looking at this going, if there's specific bits that you haven't figured out where I've got the numbers from, put it in the comments box. Let me know. I'll go through it again. Okay, more than happy with that one. Right, let's choose a different chemical reaction then. I'm going to go with... Let's do magnesium hydroxide with hydrochloric acid. Don't worry about what salt's forming at the moment. I'm going to go through that in another video at the moment. The key thing is actually learning the scaffolding for doing these calculations. So we make magnesium chloride and water. Remember, next step we need to do is balance this equation, which we can do by putting that there and that there. I've done this a few times, which is why I can go through it a little bit quicker than that. Drop my table back in. And I'm just going to write in this. So let's just say I'm working in the chemical industry and my employer wants me to make 2 ton of magnesium chloride salt. Perfectly reasonable quantity. 2 ton would be 2,000 kilograms, which would be 2 million grams. So we're using some big numbers, but actually the sequencing for everything we've done so far is exactly the same. So I want to make 2 ton. You could put it in standard form if you want to, as a bit of practice. So 2 ton of magnesium chloride. So remember the next step was to put the mass that I know in here. I've put the mass in there. What I now need to work out is how much of these am I going to need to buy to make 2 ton of this salt. So the next step hasn't changed. I'm going to go through and work out the molecular masses. I'm just going to do this a little bit quicker. You know how to work these out. You can double check my working out if you need to. From the periodic table, magnesium's 24, chlorine is 35.5, oxygen is still 16, hydrogen is still 1. So times 2 plus. So the mass of this one is 95. The mass of this one is 36.5. Water is 18. $58. Hang on, let me just double check my maths. So I'm just going through, literally just doing the calculations that we did before. 95, 18. 58. Okay. Yeah, cool. So I've just gone through and worked those out, same way as I would normally do. I'm just not writing them down at the moment. You've seen that. Go through in exactly the same way as I've done before and have a go and double check with yourself. So first things first, divide down. Like I said, the reason I scaffold this way is whenever we're working our way down the table, we always divide. Whenever we're going back up the table, we always multiply, just to keep the maths easy. However, if you want to double check, we're only using those formulas that I wrote in the top of the page at the very, very start. So moles equals mass over. I'm using that. I've just put it into a scaffolding thing to make sure, so I don't really have to think about it as I'm going through. So let's do this first calculation then. 2 million divided by 95 is 21,000 moles. Okay. I'm going to look at my ratios again. 1 of those to 2 of those to 1 of those to 2 of those. So therefore, I'm going to need twice as many hydrochloric acid as magnesium hydroxide. So I'm going to multiply this number by 2, which should be 42,106. Going back up, I multiply. So we're multiplying this number, multiplying this number. I would need 1, 2, 2, 1. So I would need 1,221,074 grams of magnesium hydroxide, or in other words, 1.2 ton. And if I do the other calculation, let's have a look. We've got 42,106 times by 36.5. And I would need, I'm just going to do it straight into tons, 1.5 ton of hydrochloric acid. Okay? So, let me know if any of that is not quite right. If any of that's a little bit confusing. What we'll do is I'll finish it there for the moment. We'll finish it there for the moment. I'm going to drop onto Google Meet for a little bit so you can sit there and go and scream at me and go, actually, what were you talking about here? Also, have a think about any questions, because when we do Wednesday's lesson, I can then go through and I can pick up any other issues and we can look at some other exam questions and we'll do some more practice at this. But everything comes from this scaffold. I'm going to drop the scaffold sheet into Google Classroom as well so you can have a look at it. Okay? I appreciate that's quite hard today, but that's as hard as it will ever get in any of the exams on these particular questions. It's just a case of learning that routine. Yeah, absolutely. We'll go through, we'll do this again, and I'll set you loads of problems. Literally, every time you do it, just follow the same steps each time. Write the equation, balance it, copy the mass in, work out the molecular masses, which is all things that you did last lesson. Yeah? All things that you did last lesson. Divide going down the table, multiply going back up. What it's doing is it's taking 2 or 3 different areas and combining it into a useful problem. Right, guys, get onto Google Meet in a moment and let's have a quick chat about this, okay? I've got to go anyway, but I'll stop this, I'll save it, and I'm going to put the link into Google Meet, and we'll have a quick 10-minute chat, and then we'll go through more of this on Wednesday when you've had a chance to think about it and practice it. Okay? Take care. I'll see you on Google Meet in a minute. Make sure you're all there.